Hello everybody and welcome to the Bowtie Teacher. In this video we're going to be going through the June 2019 IGCSE Paper 1 HR. Let's get to it. So for question 1 we have a cylinder and it's asking us how much depth there would be with 1.5 litres in these particular dimensions. So what's a little bit confusing is that we've got this 10 centimetres here which can encourage you to actually work out the volume of this cylinder, but that's not what we want. We want the volume of the cylinder if we had 1.5 litres of water in there. So 1.5 litres would be 1,500 centimetres cubed. Okay, so we need to bear that in mind, that that's going to be our volume, but we only have a radius of 8.2. So the volume is equal to, the formula's in the front, it's pi r squared h, and the depth of the water is actually going to be the new height, kind of like this, and we need to see how high that's actually going to be. So the 10 centimeters we don't actually need. So the volume is 1,500, and that's going to be equal to pi multiplied by the radius squared. In this case the radius is 8.2, and our h is the thing that we're going to find out. So we can rearrange this to get 1,500 divided by 8.2 squared pi. So let's try that one. We've got 1,500 divided by 8.2 squared pi. 7.100. So correct to one decimal place, the height is going to be 7.1 centimeters. Question 2, each interior angle is 162 of a regular polygon. That's quite important that we have that regular polygon. And if we try to draw what this would kind of look like, then we would have something that looks like this, and we're looking at the interior angle is 162 degrees. Work out how many sides this polygon would have. So there are two ways of doing this. The easier way is to actually work out the exterior angle, which is 180 minus 162. So that's going to be 18 degrees, and the number of sides, so the exterior angle is the 360 divided by the number of sides. So we can rearrange this to get 360 divided by 18, which is 20. So this would be a 20-sided shape. Alternatively, you can use the formula for the interior angles. So the interior angle is number of sides minus 2 times 180 divided by n, and that gives us 162. So we could times both sides by n, and we would have 180n minus 360 is 162n, and we can rearrange this to get 18n equals 360 and have the same calculation as we had before. Okay, but this first way that we did it here with the exterior is, as you can see, a lot less complicated. For question 3, we've got some sets here. So list the members of the set A, and then we've got the n there, that means intersection or and. And if you can remember the and, it makes this question a lot easier because we want A, even numbers, and multiples of 3. So we're looking through these numbers for even numbers and multiples of 3. So that would be 12. We would discount 15 because that's not even, and 18. For part 2, we have even or a multiple of 3. So we want all the even numbers or multiples of 3. So we're going to have 12, 14. We would include 15 in this case because we're allowed to have them evens or multiples of 3, 16, 18, and 20. And then this notation here, not A, So not even, or we could just say the odd numbers. So the odd numbers within this set. So 11, 13, 15, 17, and 19, like so. So try to remember what these words actually mean. Question 4. We're going to collect all the x's, so we're going to subtract 4x from both sides. And then we're going to take 17 from both sides, like that. So negative 13 minus 17 is negative 30 equals 4x. So x equals minus 30 divided by 4. X equals minus 7.5, I believe. Let's just check that on the calculator. So we can actually type in algebra on our ClassWiz calculator using the alpha equals, so not this equals down here, the red equals button, 17 plus 8x. And then we use the shift solve button, and this x equals 21 is not the answer, this is the last answer I got from using this, so we can just put any number into there and start the process. And when you see the L minus R, that tells you that the calculator's actually worked out this answer correctly. L minus R equals 0 means that the left hand and the right hand side are equal, so minus 7.5 is the answer there. It's really handy to check your algebra using your calculator. Question 5, write 720 as a product of its prime factors. This is the old cherry trees from year 7, so we can also use the calculator here to check our answer. We can't just put the answer and expect to get the answer correct. We have to put 720 and press equals, and then the shift fact button. So you can see the degrees, seconds, and minutes button, or the time button there. Above that it says fact, so it's going to factorize that for us. So we know our answer should be 2 to the power of 4 times 3 squared times 5. So we know our answer should be that. We just have to make sure that we get that from our cherry trees. So 720 to 360 to 180 to 90 to 45, 3, 15, 3, and 5. 1, 2, 3, 4 2s, 2 3s, and a 5. So we know straight away that we've got that correct. For part B, find the smallest whole number that 720 can be multiplied by to give a square number. So for a square number, we would have even powers in all of these, because then we would have square numbers in here. So, you know, we have 2 squared already for the 2 to the power of 4. We have the 3 squared, and then we have the 5. That's an odd power because it's power of 1. So we need another 5 in here. This is the number we need to multiply to give us our square number. So the answer to that would be 5. For question 6, Lorenzo increases all the prices by 8%. Before the increase, the price of a dessert was $4.25. So we're going to do 4.25. Now you can work out 8% and then add that on, or you can just multiply by 1.08, because this is 108% as a decimal. So 4.25 times, we could do 108% as well on the calculator, 4.59, so $4.59. After the increase, the price of lasagna is $9.45. Work out the price before. So this is a reverse percentage question. So the $9.45 is the same as, well, it was an 8% increase, so that would be 92% of that price. Okay, so we can't just take 8% off of the new price. We have to do it in this way. So sorry, not 92%. This is 108%. $9.45 is 108% of the original. So we can turn this into a decimal like this, and now we have an equation that we can solve. So we divide both sides by 1.08. We get x equals 8.75. Okay, so this is 108% of the original price, and we can work backwards from there. For question 7, we have an isosceles triangle, and we have to work out the area, so we need to have the base. So we're going to do a triangle here, right angle triangle of 7.5 and 6. So let's call that M for the midpoint. MC squared is equal to 7.5 squared minus 6 squared. So MC is going to be the square root of that. $20.25. And we're going to square root that value. 4.5. So MC is 4.5. We've only actually got half the distance across there. So we have to bear that in mind when we're working out the area of the whole triangle. So half base times height, we're going to do half the whole of the base now is going to be 4.5 times 2 multiplied by 6. So we're going to have 3 times 4.5 times 2. That gives us 27 centimeters squared for the area. Question 8 is a weighted means question where we have to work out the new mean once we've taken away some information or added some information. So there are 10 people in the lift. They have a mean weight of 79. So the total weight before we did any calculations is 79.2 times 10 kilograms. 3 of these people get out and their mean weight was 68. So the total for the 3 people would have been 68 times 3. Is that 204? 68 times 3. Yep, 204 kilograms. So now the combined weight of the 7 people that are left is 792 minus 204. It's 588. That's not right. Yes, it is. So 588 kilograms for 7 people. So the mean will be 588 divided by 7. 84 kilograms. Okay. Question 9, we have some algebra. T to the power of 9 divided by t cubed. We're going to subtract the powers to get t to the power of 6. We're going to add the powers for question B to get w to the power of 12. And then when we have the brackets, we're going to do each of these separately. So x cubed and y squared cubed, like that, to give us 125x cubed y to the 6, because we multiplied those 2 powers there. Question 10, changing units is something that the examiners have identified as a problem, and they're going to keep doing this until students get it right. So make sure you can do these. 22 meters into kilometers. So we have to divide by 1,000 to get it into kilometers. And then, so that's 22 over 1,000 kilometers per second. And then we're going to be doing this in an hour, so we have to times this by 60 to get kilometers per minute, and then times by another 60 to get kilometers per hour. So the total calculation here is 22 over 1,000 multiplied by 60 and another 60 again to give us 79.2 kilometers per hour. Now, when you do this, if you do this wrong, then you'll get a stranger answer here. Let's think about 22 meters per second. An Olympic sprinter would be running at approximately 10 meters per second. So, and 10 meters per second is about 36 kilometers per hour. So 22 meters should be just over double that. But if you're getting answers of thousands of kilometers per hour, or maybe 0.002 kilometers per hour, then that gives you an indication that you've gone wrong somewhere up here. So try and bear that in mind when you're changing these 22 meters per second. Try and relate that to the Olympic sprinters. Question 11 is a ratio question. 3 years ago, the ratio of Tom's age to Clemmie's age was 2 to 7. He's now 15 years old, and Clemmie is X. So 3 years ago, Clemmie. 3 years ago, he would have been 12. And we don't know what Clemmie would have been at that point, but we know that the ratio is 2 to 7. So if we divide by, to go from 12 to 2, we divide by 6. So we would do the reverse in this process. 7 times by 6 would be 42. So 3 years ago, Clemmie was 42. So we now have to add on the extra 3 to get 45. You can use your calculator for ratios if you wish. There's a ratios button down here. In this case, we know A and B, the ratio. C we know, but X over here, if you try and match it up with this A to B, X to D, or A to B, C to X, it's number 2. So we've got the ratio of 2 to 7. And we know Tom's age was 12, so Clemmie's age will be 42 at that moment in time. Question 12, pressure equals force over area. When you put the box down on its different sides, you'll get different pressure depending on the area of what's happening on this box. So the pressure is 105 newtons. The force is 105 newtons, so the force is 105. The box is 5 by 4 by 3. So we have a box 5 by 4 by 3. So because we're dividing by the area, if we have a large area and we're dividing a force by a large area, that would give us our lowest pressure. And if we have our smallest area on the bottom of this fraction, that would give us our largest pressure. So the smallest possible area we could get would be to put it on this or the other side, the 3 times 4. So 105 divided by the smallest area is 3 times 4. And our largest area, 105 over 5 times 4. That would be our largest area. So we can do 105 over 12 is 8.75. And 105 over 20 is 5.25. So that's the largest pressure and the smallest pressure. So the difference between these, P minus Q, I would subtract those, so 8.75 minus that answer gives us 3.5. So P minus Q is 3.5. Venn diagrams, shading the set, we have to try and interpret what this code means. So we want the union of A and B would be all of the thing inside A or B, but the little apostrophe outside means it's not. So it's actually everything outside those 2 circles. So essentially it's kind of like all of this outside of the circle, and it's also and the intersection with C, so it's got to be inside C as well. So we're looking at where the pink and the red intersect. So if we just erase all of this, then the only part which was shaded would be this part here inside C, but outside of those two circles. For question B, we have to use set notation to describe the shaded region. So as you can see, it's kind of the union of these two. It's the union of these two, but it's missing everything that's outside of this circle here. So it's the union of D and E, and it has to be inside of F as well. So it's got to be inside of F and the union of D and E. There are probably a couple of ways of writing this in the exam that you could be accepted for, but that would be the most straightforward one. Question 14, probability. So we always just fill in the branches to make sure that they add up to 1. When Barney goes to college by bus, the probability that he'll be late is 0.2, so we can just fill in that branch like that. When he walks, the probability that he'll be late is 0.1, so we have a 0.9 like that. We're just making sure the branches add up to 1. Barney will go to college on 200 days next year. Work an estimate for how many times he'll be late. So to be late, he would go bus and late, 0.3 times 0.2. And he could walk and be late by going down those two branches here and here. So the first two are there and there. And we would then add those two together to get the probability that he'll be late regardless of how he gets to college. So 0.3 times 0.2 is 0.06, 0.7 times 0.1 is 0.07, so we add those to get 0.13. That's the probability that he'll be late, and then we just multiply it by how many days he's going to be at college. So 0.3 times 200 is 26, I think. Coordinate geometry is very difficult. Let's see what's going on in this question here. We have a straight line with the equation 2y equals something here. We always try and get it in the form of y equals mx plus c. So we have to divide everything by 2. So we'll have y equals 3x minus 5 divided by 2, 2.5. That tells us our gradient is 3 and our y-intercept is negative 2.5. So if we were to draw this, we would have a gradient of 3 and it crosses at minus 2.5. So it'd be quite a steep line like that, L1. L2 is perpendicular to that and passes through the point 9, 1. So 9, 1 would be kind of down here and it's perpendicular to that. So it's kind of going up like this. Okay, it's a good idea to try and draw these sketches to give you an idea of what's happening. Going through the point 9, 1. Oh, sorry, 9 minus 1. So it'd actually be sort of down there. We need an equation for L2. So for L2, the gradient, we take the negative reciprocal. That means we do minus 1 over the gradient of the other line. So in this case, 3. So the gradient of L2 in purple would be negative a third. And it goes through 9 minus 1. So we're going to replace the y and the x with those coordinates. So negative 1 for y equals minus a third. The x value is 9. And we're trying to find out the new c value, the new y-intercept for the purple line. Minus 1 equals minus 3 plus c. So c equals, add 3 to both sides, we get 2. So the equation for L2 would be y equals minus a third x plus 2. It asks for the answer in the form of ay plus bx equals c, and it doesn't say whether they have to be integers or not, so we just have to put this as a y equals, y plus a third x equals 2 to get it into that form there. Question 16 is about displacement, velocity and acceleration. As soon as you see displacement, velocity and acceleration, you're expected to do differentiation. Okay, you cannot work these out using speed equals distance divided by time or anything like that. You have to differentiate this. So the displacement, s, when you differentiate it once, it gives you the velocity, and when you differentiate it again, you get the acceleration. So let's try and differentiate the displacement. ds by dt is the notation, but if you use dy by dx, it's not that big a deal, but ds by dt is the velocity because we've differentiated the displacement. So we're going to differentiate 40 cubed, and we get 3 times 4, and then we reduce the power by 1. The next term is 6 times 2, so minus 6 times 2, 12t, the power reduces by 1, so that's t to the power of 1, and 5t, that just differentiates to 5. So that would be our velocity expression there. Find the time at which the acceleration, so the acceleration is the second differential, so we're going to differentiate the velocity to give us 24t, so I've differentiated this term, minus 12, and the 5 would just differentiate to 0. So this is the acceleration. And it wants to know the time at which the acceleration is 6. So we're going to replace 6 with a and get 24t minus 12 equals 6. Rearrange this. 24t equals 18, so t equals 18 over 24, which is 3/4, so 0.75 seconds. Question 17 is a histogram question, and in histograms we need to know the formula that the frequency density is the frequency divided by the class width. If you can remember that, that will get you through 9/10 of the questions. 24 passengers are aged between 40 and 60. So this bar here is worth 24 passengers. The class width is 20 from between 40 and 60. So the frequency density is going to be equal to 24 over the class width of 20 is 1.2. So we know that this height of the bar is 1.2 on this scale. So if that's 1.2 there, then it follows that this must be 1, 2, 3, 4, etc. Okay, because that's 1.2, then you can divide this scale up into its 6 blocks, and each block is worth 0.2 of the tiny squares. So now that we've done that bit of information, we can work out the rest of the bars. 10 here times 0.4 would be 4 passengers. 10 times 1.8 is 18 passengers. 5 on the width and 6.4. 5 times 6.4 is that 30. 5 times 6.4. 32. This one is 15 times 2, so that's 30. And this one is 20 times 0.8 on the height, which would be 16 passengers. So 16, 24, 40, 70, 102, 120, 124 passengers in total. For part B, a passenger is picked at random. Work an estimate for the probability that they're older than 55. So 55 would be this area here, plus this one that we've already worked out. So 16 there. This one would be 5 times 1.2 for the height. That gives us 6 passengers. So we would have 16 plus 6 out of 124 in total. So 22 out of 124, or 11 out of 62. Okay, 11 out of 62 will give you the correct answer there. Okay, question 18, triple brackets. We would multiply out 2 of those brackets and then do the third one after. So you can choose any of these to do. So let's do the first 2 first. X times 2x, 2x squared, plus 3x, plus 2 times 2x, plus 2 times 3. And that's all going to be multiplied by x and negative 7. So let's just tidy that up a bit first. 2x squared plus 7x plus 6. And then we're going to multiply that by x. So we're going to times it by x first. So we'll get 2x cubed plus 7x squared plus 6x. That's doing the multiply by x. Then we're going to multiply by negative 7. So we're going to do minus 14x squared. This is the top line multiplied by minus 7. Minus 49x minus 42. We can collect all these together to get 2x cubed plus 7x squared minus 14x squared plus 6x minus 49x is minus 43x minus 42. For part B, we need to make m the subject, and m is on the top and the bottom of a fraction. So we know we're going to be doing some rearranging and factorizing here. So we're going to do p squared times the denominator first. That will clear the fraction. So we multiply this out. 2p squared m minus p squared y equals x plus m. We want m as the subject, so we can collect the m's on the left-hand side or the right-hand side, it doesn't matter. And we're going to take the p squared y over the other side, like that. Factor the m, and then divide through by that bracket to get our final answer, over 2p squared minus 1. There'll be variations of this that you can have depending on where you put your p squared y in front or after, or you could collect the m's on the other side. All of those variations will be allowed. Question 19 is a sequences question. The formula for the sum is at the front, but the one that you don't have is the nth term. You have to learn this. Nth term is a plus n minus 1d. So the 25th term is 44.5. So they're telling you that the 44.5 is a plus n, 25, minus 1 is 24d. This is the first of our simultaneous equations. The second is that the sum of the first 30 is 765. So the formula in the front is the sum of the terms is n over 2, 2a plus n minus 1d. So 765 is 30 over 2 times 2a plus 30 minus 1d. We'll clear that up a little. 15 times 2a plus 29d. Does 765 divide by 15? Yeah, so 51 equals 2a plus 29d. You can multiply out the brackets if you want. This is our second simultaneous equation. So if I take the first one and multiply it by 2, then I would get 89 equals 2a plus 48d. and then I can subtract these from each other. So 48 take away 29 is 19d. These take away each other will cancel out, and 89 take away 51 is, have I done that correctly? 38. So D equals 38 over 19 is 2, and then A is equal to 44.5 minus 24 times D. So 44.5 minus 48 minus 3.5. So we've now worked out A and D, and we can now find the 16th term. 16th term is going to be A plus 16 minus 1 times D. Negative 3.5 plus 30. 26.5. Like that. Now I'm just going to check using my simultaneous equations function. Number of unknowns is 2, so I'm going to do, let's start with our original one. A is 1, that's the coefficient in front of the A, the number in front of the A. D can be 24 and 44.5 for the constant term, and then the second equation was 2A, 29D, and 51. So X, which was A, was minus 7 over 2, which is correct, and Y was 2, which was the D. Okay, lovely. Question 20. We have a term here, or an expression for A, which is in standard form. Went out of my mind there. A is in standard form, and remember, standard form should really be like 2.5, and then we raise the power by 1 here. But it wants to have an expression for A to the power of 3 over 2. So we're going to take 25 times 10 to the power of 14n and raise it to the power of 3 over 2. Because this is A to the 3 over 2, we just take this whole thing and do the same thing. What do we do with these powers? Well, we take each one separately. 25 to the 3 over 2 times 10 to the 14n to the 3 over 2. 25 to the power of 3 over 2, you're going to take the square root and then cube it to get 125. And then when we have powers here, remember that we would multiply these two. So we've got 14n times 3 halves. So 14 times 3 halves will give us 21. So this is 10 to the power of 21n. So this is actually a to the 3 over 2, but in standard form we cannot have 125 here. We have to divide this 125 by 100 to get it as 1.25, because the decimal has to be between 1 and 10 in standard form. So what we've done is we've actually divided this by 100, so we need to increase the power of 10 by 100. Okay, so in that case we would add 2 to the power of 10, because we would then do 10 squared, which is 100. So a little bit strange, that one, but hopefully you can see that I've gone from 125 down to 1.25, so I would add 2 to the power. Transformations of graphs. We have a coordinate 4, 3. When we have the transformation inside the bracket like that, that affects the x. If it's outside the bracket, it affects the y. So the -5 will actually change this by moving it to the right. It's the opposite of what you think it's going to do. So this would be 9, 3. And in front of the f of x, 3 lots of f of x. If you think about what happens here, we're now saying that the y is 3 times what it was for f of x. Here, y was 3, so it's going to be 3 times bigger than that. The x doesn't change, so that's now going to be 4, 9. Part B was very difficult here. Notice that there's no change inside the brackets in terms of like plus or minus. So we can't shift it left or right. What we have to do is we have to either multiply it by something to stretch it, and the b in front of the x means it's actually going to be a squash. So if we look at the original curve for sine x, it would be like this on this scale. And it would go down to -1 and back up. So straight away we can see that we have one wave, if you like, in the normal sine curve. And here we've got 1, 2, 3 waves. So we know that it's been squashed by a factor of 3, and that is the b term. So b would be 3. So if I just maybe get rid of this and now draw what sine 3x would look like, then you would have 3 waves in there, and we would have something that looks like this. So it's hard to draw with them. Like that. Okay. So this would be sine of 3x. Now how do we get from this to down here, this to up here? There must be a negative sign in there somewhere to reflect it in the x-axis. So if we do minus sine 3x now, I'm sort of going through this slowly to try and take you through my thought processes. So negative sine of 3x would be down here. I'm just going to draw a couple of these. So you can see now that we've now got minus sine of 3x, but it still needs to be stretched by a scale factor of 2. So we need a 2 in front of this to get from the purple to the black line there. So a would be -2. In the exam, you can take some time to sketch out what would happen with your transformations and see how you would then manipulate that to get to the graph that they ask you to do. Question 22, quadratic equations with simultaneous. All we do is we take the y and we substitute it into the original here. So we've got 2x squared plus 3 lots of y squared. So that's going to be 2x plus 1 squared equals 5. So let's multiply out the 2x plus 1 squared. And we get 4x squared plus 2x plus 2x plus 1, which is 4x squared plus 4x plus 1. So we can now replace all of this in here. So we've got 2x squared plus 3 lots of 4x squared plus 4x plus 1 equals 5. 2x squared plus 12x squared plus 12x plus 3 equals 5, and we need to rearrange this to get a quadratic. 14x squared plus 12x, so I've collected those two together, and now I need to bring the 5 over to make it equal to 0, to make it a -5, so we'll get -2 equals 0. Each of these has a factor of 2, so if you wish you can divide through by 2, and we can then factor this. So we'll have a 7x and an x, and we have a 1, so we have to have a 1 and a 1 here. We need positive 6x, so we're going to do plus there and a negative there. So our x value is -1 or a 7th. And then our y value, we use our original equation in the linear term to get this. 2 lots of x minus 1 times 2 plus 1 is also -1. And then a 7th times 2 plus 1 is 2/7 plus 1 is 9/7. So our final answer is -1 minus 1 and a 7th, 9/7, like that. Okay? You can check this on your calculator menu, go down to the equation function, and polynomial of degree 2, because it's a quadratic. Let's start with the original one in case I made a mistake. 14, 12, and -2. So get a 7th and -1 like we got there. Okay. Question 23 is a circle theorems question. So we need to identify which circle theorem is actually involved in the question. There's no center, there's no tangent. So the only thing that we can use is cyclic quadrilateral, which means that the two opposite corners will add up to 180 degrees. So if we split this shape into separate triangles, we would have a 54 there. This angle here we don't know, and this angle here, well, it's opposite this one here, so this is 180 minus x. 180 minus x, because those two add up to give 180. So we can say that 54 plus y plus 180 minus x would be equal to 180, because all three of those add up to 180 degrees. So y plus 180 minus x is equal to 180 take away 54. And we can cancel the 180s from both sides. Y equals x minus 54. So I've just rearranged that to find y, which is in here. We can then make another triangle B, C, E, 32, x, and y. This time we're going to substitute the y for x minus 54. So adding up these three angles, x minus 54 plus 32 will give us 180. X plus x minus 54 plus 32 equals 180. So 180 plus 54 minus 32 will be equal to 2x. So 2x equals 202. So x equals 101 degrees. Okay? Question 24 is a vector question, and this one's quite tricky. So what we're going to try and do is break this down into its smaller parts and see if there's anything we can do to figure out what's going on. What we need to consider is O to P, and as you can see, that's on a straight line. So what that means is that the ratio of A's to C's will be the same as the ratios of A to C's to go from O to Q and Q to P. There'll be different lengths, but the ratios of the A's to C's will be the same. So let's try and work out what O to Q is first of all. Now it looks like these are it looks like Q is halfway between A and C, but we don't know for certain that that's the case. So we're going to give this a letter, maybe K, and we're looking at the ratio of AQ to QC. So if we can find the value of K, that will be some fraction of the distance from A to C. O to Q, we need to go from O to A, and then A to Q, like that. So we're going to start at the origin, we're going to go O to A and A to Q. Now A to Q, as we've said, is K lots, so it'll be a fraction of the distance from A to C. And A to C will be negative A plus C. So we've expressed that distance as a fraction of the distance from A to C. We don't know what that fraction is. It looks like 50-50, but it probably isn't. So O to A, we need to go A plus A to Q. So K minus A plus C, like that. And we can kind of tidy this up a bit. A plus KC minus KA. And if we factor out the A's, then we would have 1 minus K A plus KC. So this is the vector to get from O to Q. Now if we do the same thing for Q to P, what we can do is we can go Q to A plus A to P. From the question, A to P is in a ratio of 3 to 1, and the whole of that vector is 2c, so it's 3/4 of 2c. 3/4 of 2c would be 1.5c to get us from A to P, and 0.5c to get from P to B. So QA, if we're going from Q to A, we're going in the opposite direction of A to Q. So we're going to do the opposite of this, minus K minus A plus C. So we're going to go in the reverse direction. That's to go from Q to A plus A to P 1.5C. So we would have KA minus KC plus 1.5C, and that will give us KA plus 1.5 minus KC. So I'm just factoring out the C's so that we can see the ratios of these things to each other, because I said that the ratios O to Q and Q to P will be the same. So we have 1 minus KA, and the KA here, I'm expressing these as fractions because ratios are fractions. That will be the same as the ratio of KC to 1.5 minus KC here. So I'm showing you that the ratio of these two A's, so the A from this one and the A from this one, is the same as the ratio of KC to 1.5. I'm just going to cancel out these because they're not necessary anymore. So let's do it in a different color so it's easier to see. We now have 1 minus K. I'm going to cross multiply the K's and these brackets here to get 1 minus K. 1.5 minus K is equal to K times K, K squared. Multiply out this brackets, 1.5 minus K minus 1.5K plus K squared is equal to K squared. So I can cancel the K squareds, and I get 1.5 equals minus K minus 1.5K is minus 2.5K, and take it over the other side to get positive 2.5K. So our K is equal to 1.5 over 2.5, which is equal to 15 over 25 is 3/5. Okay, so that was pretty tricky. We found K to be 3/5 of the distance from A to C. That K there is a fraction of distance. So we have 3/5 here, which must mean 2/5 from Q to C. So our ratio of A to Q, 3/5 to Q to C, sorry, to QC is 2/5. So that gives us a ratio of 3 to 2. Tricky, very tricky. The ratios thing is very difficult. It's kind of like an A-level question brought down to GCSE. So we're just trying to see that the ratio of these two things are the same and seeing if we can solve that equation. Question 25 is a bearings question. So let's try and make this into a picture that we can decipher. We've got point X to point Y and then to point Z. So we'll start off with X. Let's just do a rough sketch for now. We're going on the bearing of 280 to get to Y. So a bearing of 280, remember we take it from the north line. 280 is about west, but a bit more. So we're going to go in this direction to Y. That's 280 degrees. And then Z is on a bearing of 220 from Y. So 220 is kind of down there. That angle in there is 220 to Z. The distance of X to Y is 3.5 and the distance of Y to Z is 6. And work out the bearing of Z from X. So we need that line in there. Okay, so let's kind of try and tidy this up a bit. We're going to go 280 to 220, and we're going to have another triangle going back up there. Let's just get rid of all this. So we're going to go from X to Y to Z. This angle in here is 280 degrees. This angle from here down to here is 220 degrees. And we need to find out this angle here, just to that point there. The extra information that we have is a 3.5 and a 6. So what we can do is we can try to find out some angles in here and some length as well. If we can try to find out this angle in here, that would be 360 minus 280. So that would give us 80 degrees in there. So that would put, if I draw this kind of line down here, that would be 80 in here, and then another 40 degrees in there, because we've gone from 220, we've gone 180 plus another 40. So in total in there, we've got 120 degrees. So 3.5, 6, 120. That'll allow us to work out this side here. Let's call that A. So A squared equals B squared plus C squared minus 2BC cosine A. Like that. We can substitute in for the two sides, it doesn't matter which way round. Like that. And so we can try to work out the value of A. So 3.5 squared plus 6 squared minus 7 times 6 times cos 120. 277 over 4, and then we square root that to get root 277 over 2. So that's the side A, root 277 over 2. Now we need to work out this angle in here. So once we've done that, we would be able to work out this bit here and get the whole bearing. So if we use sine rule now, then we can do sine 120 over A, which we just worked out, is equal to sine, let's call that theta, sine theta over 6. So sine theta is equal to 6 sine 120 divided by A, and then theta is going to be the inverse sine of that. So we can do let's store that in A. So that's our A. 6 sine 120 divided by our A value is 0.624, and I'm going to take the inverse sine of that answer to get my angle of 38.6 degrees. So theta is 38.6. I can add it to the 80 here and then take that away from 360 to give me my final bearing. So theta plus 80 degrees, we're going to do 360 minus that, and that will give me my bearing, hopefully. So we're going to add 80 to this, and then do 360 minus that final answer. That gives us 241.36 degrees. So give your bearing correct to one decimal place, 241.4 degrees. Okay. So that's the end of the test. There's some really tricky questions in there. Approximate grade boundaries, we're looking at 50% for a 7. So if you can get up to question 12 or 13 without any problems, then you're looking at a grade 7 and 75% for a 9, about 63% for an 8. So try hard to work on these questions that keep coming up. The questions that they're doing, the transformations of graphs is very common, quadratic equations, all those sorts of things that I mentioned in the video. They're the things that you need to make sure that you can do because they come up every year. And if you take the time to read the examiner's report, which I recommend you doing, you can see that they're recommending students to improve on these skills, and they're going to keep asking those questions because that's their kind of agenda to get that improvement from the students. So I hope that was useful, and good luck in your real thing.